So on this video, what we're going to do is we're going to use both first and the second derivative and find out everything about the original graph. So we're going to find out the slopes, whether it's increasing, decreasing, or where it has minimum and maximum, as well as the cups and the inflection points. So that way we can actually see what the first graph looked like. Okay, so let's take a look at this one. So in order for us to do that, we're going to need both first and the second derivative. Now the thing about this is that I know we can take the derivative of this straight without making it pretty, and by doing that we'll have to do low d minus high d low on my second term. However, we're going to make this pretty, so I'm going to leave the x as it is. But on my second term, I'm going to bring the denominator up. By that I mean it's going to be the x minus 4 to the negative 1. I have not taken the derivative yet, but I did make it pretty in order for me to take the derivative easily. So now let's take the derivative of this. So this will give me f prime of x equal 1. And then my second one, this is candy and wrapper, right? So it would be negative 4, right? Negative 1 times 4 times x minus 4, candy as it is, take away 1, times the derivative of the candy, which is just 1. Okay? Now if I were to make this pretty, this just becomes 1 minus 4, x minus 4 to the negative 2. Now I'm going to go ahead and take the second derivative because I know I can set it equals 0 and all of that stuff, but I'm going to wait a little bit and actually take the second derivative of it first. So I'm going to do my second derivative on this side. Okay? So my second derivative of this would be derivative of 1 is 0. And when I take the derivative of this, remember this is my wrapper, so negative 2 times 4 is 8. And x minus 4, take away 1, times the derivative of the candy, which is just 1. And this really just becomes 8x, oops, I don't know why they did that, 8x minus 4 to the negative 3rd. Now here's what we're going to do. We're going to do what we usually do. We're going to figure out when things have positive, negative, and increasing, decreasing, min, max, and all of that stuff. But before I do, let's go ahead and talk about this thing that we did in class. My first function, my original function, when I look at this, you see how this is a fractional function, and when x equals 4, if that x was 4, I get a 0 on my denominator, which means at x equals 4, I know I'm going to have a vertical asymptote. I don't want you to do anything with this, but I just want you to know that that's where we would have a vertical asymptote. And I know I get confused about vertical asymptote and vertical tangent, but try to think of it like this. Last year, that's when we learned about vertical asymptote. Last year, we knew nothing about the derivative. We knew nothing about tangent. So last year was the year that when we only worked with the original function, and that's when we learned about vertical asymptote. So that's on that. If this is vertical tangent or horizontal tangent, that has to do with the derivative, because that's what we learned this year. I hope that you guys can categorize that in that way, if that helps you. But I'm just letting you know that distinguishing it, we don't need it right now, but I'm just pointing that out because that's what we did in class. All right, so now in order for me to kind of figure out what's happening with the first derivative or our slopes, we're going to have to see when this is going to equal 0. But before I do, I'm going to rewrite this in a way that's going to be easy on my eyes. So I'm going to bring that negative 2 power to my denominator, and it's going to look somewhat like this. Now take a look. Do you see how this is my f prime. This is my first derivative. My first derivative itself on the denominator has an x, which means not only do you have to set this equal 0, we also have to set this equal does not exist. But we're going to deal with this one at a time. This is when my first derivative equal 0. I'm going to do this on this side. Okay. All right. So my first derivative, which is that, we're saying that right there is going to equal 0. Now, I know it looks complicated, but it's not that bad. Do you see how there's two different terms there? And those are set equals 0, so I'm going to move one of them to the other side. That's a skill that we learned the other day by doing number 5 on page 13. So we're going to move, I'm going to move this 4 to the other side because that's a negative 4. So if I move it to the other side, that just becomes positive 4. Okay. Now the way that we're going to solve this is we're going to put 1 under it and just cross multiply. So I'll get 1 times 4 is 4. It's equivalent to 1 times this, which is x minus 4 squared. Now we can square root both sides. That was Madison's idea, by the way. I want you to like FOIL this out and do all this complicated math. So that gives you plus or minus 2, because square root of 4 is 2, is equal x minus 4. Now I'm going to have to add 4 to both sides. So you have to do it twice. So on this part, you're really doing positive 2 plus 4 and negative 2 plus 4. So my x's are going to be 6 and 2. Now let's stop here and kind of think about what we found, because we did a lot. We found the first derivative up there somewhere at some point, and we are setting it equal 0, and we found our x's. So this is when my f prime equals 0, or my slope equals 0. Now likewise, we're going to have to do the same way, but we're going to have to do when first derivative does not exist. We have to do this part every time we have a denominator, okay, which is not that bad. So we know the function or a slope doesn't exist if we have 0 on our denominator. So we're going to set the bottom equal 0. Only the bottom equals 0 because that's all we care about. So we have a square, so we're going to square root both sides. So we get x minus 4 equals square root of 0, which is 0. So my x is equal 4. So at this x equals 4, we know that's when our slope does not exist. Now with those facts, we are going to go ahead and do our number line analysis down here. Okay, so my number line analysis is going to look somewhat like it. So this one is for my f prime. If you're wondering why I'm doing it like in the middle of them and not on the left side, maybe you didn't wonder that. There's a reason why I'm doing it here, because at the end, I'm going to put the first derivative on top of the second derivative, and you'll see what I mean by that. So I'm going to line them up. Anyway, this is my first derivative number line. I'm going to label it because we're going to do second derivative later. So the things that we have is 2, 4, and 6. So we'll have 2 at x equals 2, x equals 4, and x equals 6. So we know at x equals 2 it was 0, and 6 it was 0, and at 4 it does not exist. We're going to plug it back into our first derivative, which was actually, what's going on? This up here. So if I were to plug in 0, that gives me, I'm going to plug in 0, 1 minus 4 over 16, which is 1 minus a small number that's than 1, so which gives you positive here. So I have a positive slope there. And if I plug in 3, it's 1 minus 4 over 3 minus 4, which is negative 1 squared, which is 4, so that gives you a negative number. And if I plug in 5, in between 4 and 6, it's 1 minus 4 over 1, which is once again negative. If I plug in 7, that gives me 1 minus 4 over 3 squared, which is 9, which is a smaller number than 1, so that gives me positive there. So that's only my first derivative analysis. Likewise, I'm going to do the same thing to here on my second derivative. As you see, once again, we're going to have to set this equal 0 and does not exist, but let's go ahead and make this pretty. So this is 8 over x minus 4, entire thing cubed. Since my derivative is a fractional looking thing and we have x on our denominator, which means I'm going to have to do both set it equals 0 and does not exist. So let's do one at a time yet again. Here we go. So we set the second derivative equal 0. So that's what I'm going to do here. So when I do, I get 8 over x minus 4 cubed equals 0. Once again, we put 1 under 0, cross multiply. 8 times 1 is 8 equals 0. Well, guess what? They don't equal 0. So this one, I don't have any answers for when it equals 0. It's never going to equal 0. However, let's assume an f double prime of x does not exist, which we always have to check for that. So we're going to set the denominator equal 0. So if I take the cubic root of those, x minus 4 equals 0. My x is equal 4. Now, at x equals 4, we know that our second derivative does not exist. But we can still do a number line analysis with that. So let's do that here. Right below our first derivative, I'm going to get my second derivative there. Okay. Now the numbers that we had when x was equal 4. So when x equals 4, we know that our second derivative does not exist, and we didn't have anything else in between. Now let's take a look. All right, so our second derivative, I see that it's up here. I'm going to plug it in there. If I plug in 0, because it's the easiest number to plug in, so I get 8 over negative 4 cubed, which will be a negative number. Okay, and if I plug in positive number, it's 8 over 1, which is a positive number there. We're almost done. I know it's been a long problem. Just hang on with me. All right, so here's what I'm going to do. I'm going to divide this up. So wherever I have x equals 2, I'm going to put a little squiggly line that indicates that I'm going to divide this thing by. I know right now this doesn't make sense to you, but it will here in a second, okay? So what we're doing is we're sectionalizing this. So on my first section, so let's take a look. Here's what I mean. On this section right here, let's see what all we got. Here's all the information that we just gathered. With the second derivative tells you the concavity, whether or not it's a positive or a negative. Since it's a negative, we know that over here it's going to be a frowny face. But along with the frowny face, it's going to have a positive slope. So it's not going to be this side of it. It's only going to be the first half. So on this one, it's going to look somewhat like it. Y'all see what I'm talking about? It's a frowny face with a positive slope. It's only going to be that portion of the graph. A variety of that portion. It doesn't have to have that concavity. On this second portion, so this is what I'm talking about now, okay? It is still frowny face, however, it's a negative slope based on our number line, which means it's going to be this portion of the graph. Let's take a look at our next portion. So this one that I'm marking in orange. It's a happy face because it's a positive second derivative, but a negative first derivative, which means my slope is negative. So it's going to look somewhat like it. Okay. Now the last portion, let's take a look. It's a positive concavity, which means smiley face with a positive slope, so it's going to look somewhat like that. There it is. So we know on this portion, my first graph will look like that, second, third, and fourth. That's it. That's it for us. Okay. I'll assign homework on your GroupMe.